Hello and welcome. In this episode, we are going to talk about the multiplicative inverse of a matrix. The multiplicative inverse of a matrix. So, what do you know about multiplicative inverse? We're talking about a number like 5. What its multiplicative inverse? It's 1 over 5. But if we are talking about a matrix, what is the multiplicative inverse of a matrix? The multiplicative inverse of a matrix, if the matrix is A, so it's a matrix. Also, it's a matrix. The multiplicative inverse of a matrix, it also is a matrix. When we multiply them, we get the unit matrix. So if we have a matrix like this one, it's 4, -2, 3, and -1. And the matrix like this one, B, it's -12, 1, -3 over 2, and 2. Multiply A by B, A times B. So we're going to write 4, -2, 3, and -1 multiplied by -12, 1, -3 over 2, and 2. Multiply row by column to get an element. So it's 4 times -2, it's -2, and -2 multiplied by -3 over 2, it will be +3. And multiply this row by the second column to get only one element. 4 times 1 is 4, and -2 times -2, it's -4. And then go to the next row, multiply the next row by the first column, so 3 multiplied by -half, it's -3 over 2, and -1 multiplied by 3 over 2, it will be +3 over 2. And then 3 times 1, it's 3, and -1 times 2, it's -2. Then simplify. -2 plus 3, 1, and here 4 minus 4, 0, and here it's 0, and here it's 1. What do you notice? We noticed that when multiplying A by B, we would get I, the unit matrix. So we can say that B, the matrix B, is the multiplicative inverse of A. Find the multiplicative inverse of the matrix A. How can we get the multiplicative inverse of the matrix A? We call it A -1. Find the determinant of A firstly. What is the determinant of A? It's 4, -2, and 3, -1. Multiply the main diagonal, 4 times -1, minus 3 times -2. So 4 times -1, it's -4. Negative times negative here, it's positive. 3 times 2, 6. -4 plus 6, 2. So it will be 2. Then the multiplicative inverse, it's 1 over 2, 1 over the determinant of A. Okay. 1 over the determinant of A. Then here's 4, and 1 over the determinant of A multiplied by exchange the main diagonal. So here write 4 and -1, it's -1 and 4. I exchange them. Exchange the main diagonal, then exchange the sign of the other diagonal. So -2, it will be 2, and 3 will be -3. Okay, so it will be 1 over the determinant of A, 1 over 2 multiplied by -1, 2, -3, and 4. So it will be half times -1, it's -half, and half times 2, it's 1, and half times -3, it's -3 over 2, and half times 4, it's 2. This is the multiplicative inverse to the matrix A. If we have a matrix like this matrix, A, 3, here 6, 2, and 9, find its multiplicative inverse. So the first step, find the determinant of A. The determinant of A is 3, 2, 9, 6. Multiply 3 by 6, minus 9 times 2. 3 times 6, it's 18, minus 18 equals 0. So it's 1 over the determinant, then exchange 3 and 6, it will be 6 and 3. I exchange them. Replace 3 and 6. Then switch off. Change the sign of 2 and 9. So it will be negative 2 and 9. And don't replace, just change the signs. 2 will be negative 2, 9 will be negative 9. 3 and 6, they are replaced. Then it's 1 over 0. 1 over the determinant. The determinant is 0, so 1 over 0 has no meaning. So this matrix has no multiplicative inverse. This matrix has no multiplicative inverse. So the matrix has a multiplicative inverse if its determinant not equal to 0. If its determinant is not equal to 0. This matrix has a multiplicative inverse if x equals what? This matrix A has a multiplicative inverse if x equals what? So this matrix has a multiplicative inverse. That means the determinant of this matrix is not equal to 0. So we'll find the determinant of A. Multiply the main diagonal, it's x minus 1, multiplied by x minus 2, minus 3 times 4. Okay. So x times x minus 1 multiplied by x minus 2, it's x squared, and here minus 3x, and here plus 2, and minus 12. And I'm going to write is equal to 0. So x to the power of 2 minus 3x minus 10 equals 0. So here we have two solutions, x minus 5 and x plus 2 equals 0. So x equals 5 and x equals negative 2. So they are only the two values which make the matrix has no multiplicative inverse. So x in this case belongs to what? X belongs to any real number except 5 and negative 2. If x equals 5 or x equals negative 2, that means the matrix has no multiplicative inverse. So once again, this matrix has a multiplicative inverse if x belongs to what? Belongs to any real number except 5 and negative 2. If we have a matrix A and we find its multiplicative inverse, then we find again its multiplicative inverse for the multiplicative inverse of A, you will get A at the end. So if you have A, any matrix, and you are going to find A negative 1 by using the steps we have learned, then you are going to find the multiplicative inverse of this matrix, you will get A at the end. And if you have two matrices A and B, and you multiplied A by B, okay, you multiply them, you will get a matrix. And you are going to find the multiplicative inverse of A multiplied by B. You know, you will get a matrix here. It's the same matrix as multiplying the multiplicative inverse of B multiplied by multiplicative inverse of A. So A, B, the multiplicative inverse of A multiplied by B is the same as multiplicative inverse of B multiplied by multiplicative inverse of A. Multiplying matrices is not a commutative property. So if we have matrix multiplied by matrix, it's not the same as B multiplied by A. A times B, the matrix A multiplied by the matrix B, it's not the same as B times A. So the order in multiplying is very important. If we have a matrix A multiplied by its multiplicative inverse, you will get I. And if you have a matrix A and you multiplied it by its multiplicative inverse, you will get I. What I want to say, the order is not important in this case. I multiplied the multiplicative inverse of A. Secondly, I wrote A firstly, then A to the power of negative 1 secondly. Then here I wrote a negative 1, a to the power of negative 1, firstly, then a secondly. And in both operations, we have got I. So if we have a matrix like the matrix A multiplied by the matrix X equals the matrix C, and I want to get the matrix X, pay attention. This information is very, very, very important. I want to get X. So we're going to write here a to the power of negative 1, the multiplicative inverse at the very beginning. Then write it here at the very beginning. The order is important. And you know that a to the power of negative 1 multiplied by a, it's I. And I multiplied by x equals x. So x equals a to the power of negative 1 c. And if I have a matrix like the matrix X multiplied by the matrix A equals C, and I want to get the matrix X, I want to get the matrix X. So we're going to multiply it by the multiplicative inverse. Here, a to the power of negative 1, and here multiplied by a to the power of negative 1. Look at the order of multiplying. Here, a to the power of negative 1 is written at the last, so I wrote here at the last. 8 multiplied by a to the power of negative 1, it's I. So x times I, x equals c multiplied by a to the power of negative 1. And this property, we use it in answering the two simultaneous equation using the multiplicative inverse of matrices. So if we have two matrices, two equations like 2x plus 3y equals 7. And this matrix is x minus y equals 1. And I want to solve them using the matrices. So here we have coefficients. We have 2 multiplied by x and 3 multiplied by y equals 7. And also here we have a coefficient in front of it, it's 1. And here it's negative 1. If you multiplied 1 by x and you multiplied 1, negative 1 by y, you will get 1. So here we have a matrix of coefficients. Write x here 2 and here 1. And write y here 3 and negative 1. If you multiply them by the variables are x and y. They are the variables. And if you multiply them, look here, it's a 2, multiply the row by a column to get an element. So it's a 2 times x plus 3 times y equals what? Equals 7. So here write the absolute values. And here it's 1. So here we have a matrix of coefficients. Here it's the matrix of the coefficients, and here it's the variable matrix, and here is the absolute value, the absolute values matrix. So here we can write instead, to make it easy, we can write the matrix A as we have learned, multiplied by the matrix X, the variables, equals the matrix C. It's a matrix multiplied by matrix, and C is also a matrix. How can we get the matrix X? Multiply here by a to the power of negative 1, and here by a to the power of negative 1. A to the power of negative 1 multiplied by a, it's I. As you know, multiplied by x equals a to the power of negative 1c. So x equals a to the power of negative 1c. So how can we get this matrix x and y? Find the multiplicative inverse of a. So here a, the matrix A, is 2, 3, 1, and negative 1. Find the determinant of A. It's 2 times negative 1, negative 2 minus 3 times 1 is 3, so it's negative 5. Then a to the power of negative 1. 2 times negative 1 is negative 2 times negative 1 is negative 5. 2 times negative 1 is negative 5. 2 times negative 1 is negative 2 times negative 1 is negative 5. 2 times negative 1 is negative 2 times negative 1 is negative 5. 2 times negative 1 is negative 2 times negative 1 is negative 5. 2 times negative 1 is negative 2 times negative 1 is negative 5. 2 times negative 1 is negative 2 times negative 1 is negative 5. 2 times negative 1 is negative 2 times negative 1 is negative 5. 2 times negative 1 is negative 2 times negative 1 is negative 5. 2 times negative 1 is negative 2 times negative 1 is negative 5. 2 times negative 1 is negative 2 times negative 1 is negative 5. 2 times negative 1 is negative 2 times negative 1 is negative 5. 2 times negative 1 is negative 2 times negative 1 is negative 5. 2 times negative a to the power of negative 1. We can write it here in this area because we don't have much room here. A to the power of negative 1, it's 1 over negative 5. And then exchange 2 and negative 1, it's negative 1 and 2. And change the sign here, 3, negative 3, and here it's negative 1. So a to the power of negative 1 over negative 5 multiplied by negative 1, it's 1 over 5. 1 over negative 5 multiplied by negative 3, 3 over 5. Here it's 1 over 5, and here 1 over negative 5 multiplied by 2, it's negative 2 over 5. Okay, then write x equals a to the power of negative 1, it's 1 over 5, 3 over 5, 1 over 5, and negative 2 over 5. Multiplied by this matrix C, a to the power of negative 1 multiplied by C, 7 and 1. So x equals 1 over 5 times 7, it's 7 over 5. 3 over 5 times 1, it's 3 over 5. Then here 1 over 5 times 7, it's 7 over 5, and negative 2 over 5 times 1, it's negative 2 over 5. 7 over 5 plus 3 over 5, 10 over 5, which is 2, and here it's 5 over 5, which is 1. So the matrix X is 2 and 1. As you know, X is 2, Y is 1. That's it. If I want to get the matrix X, so we can write instead of this matrix, it's A multiplied by X equals C. How can we get the matrix X? Just multiply here by the multiplicative inverse of A at the very beginning. So right here in order at the very beginning. So a to the power of negative 1 multiplied by 8, so I multiplied by x, so it's x. So x equals a to the power of negative 1 multiplied by c. So we need to find the multiplicative inverse of a. How can we find it? Find the determinant of a. What is the determinant of a? The main diagonal, the product of the main diagonal, 2 times 0, minus 3 times negative 1, 0, plus 3, so it's 3. And then a to the power of negative 1, it's 1 over 3. Then exchange 2 and 0, 0 and 2, change the sign 1 and negative 3. So that is going to be 1 over 3 times 0, 0, 1 over 3 here. And here it's negative 1, and 1 over 3 times 2, it's 2 over 3. Then x is going to be equal to a to the power of negative 1, 0, 1 over 3, negative 1, 2 over 3, multiplied by c, negative 1 and 3. So x is going to be negative 1 and 3 multiplied by negative 1, so it's 0. 1 over 3 times 3, so it's 1. And here negative 1 times negative 1, it's 1, plus 2 over 3 times 3, so it's 2. So it will be 1 and 3. Here it's x, and 3 is y. I hope you enjoyed this session. See you in the coming episodes. Goodbye.